Let's discuss a question from thermodynamics. What is asked is the work done in isentropic process involving ideal gas. Okay, so work done in an isentropic process. Now, isentropic process is basically when you don't have change in entropy. Change in entropy is equal to 0. Okay, and this is governed actually by PV comma is equal to constant. Okay, this is the basic equation for isentropic now. Okay, PV power comma is equal to constant. Now work done is integral PdV, and if I use this relation, that is in, let's say from volume 1 to volume 2. So if I use this equation, which is C by V power gamma and dV, so it becomes an equation in one variable. So this constant is constant. V power gamma, when you take it to the numerator, it becomes V power minus gamma, and when you take integration, it's V1 minus gamma plus 1 by 1 minus gamma. And now if you substitute the limits V1 and V2, so you will be getting C. So this is V2 1 minus gamma minus V1 1 minus gamma if I substitute the lower limit by 1 minus gamma. And now if you substitute C as okay, now still you can further simplify C into V2 1 minus gamma, so this will be 1 minus gamma minus C V1 1 minus gamma by 1 minus gamma. So now if you have to substitute, so for this C1, now remember that at the two states 1 and 2 we can substitute in this equation. So because both the state points satisfies the curve, so P1 V1 power gamma is equal to constant, P2 V2 power gamma is equal to constant. So in the first part I will substitute C as P2 V2 power gamma, and V2 power 1 minus gamma. Okay, this is 1 minus gamma minus, I'll substitute here for C as P1. I can substitute any of these two I can use. So I'm using the first part for the second term, P1 power gamma, V1 1 minus gamma by 1 minus gamma. So from this, what I get is in the numerator P2 V2 I get, because V2 power gamma and V2 gets cancelled. So 1 minus gamma minus P1 V1 1 minus gamma. Now if I take minus common from both the equations, I can write P1 V1 minus P2 V2 by gamma minus 1. So this is the work done by the system. Remember, this is work done by the system in an isentropic process. Okay, so answer for this is C. And remember that this is the governing equation. Now in fact we can derive this as well, because TDS is, if you use the equation, TDS is dH minus VdP, and for change in entropy is 0, and for TH you can substitute as MCP delta T, which is for ideal gas, and again in the delta T terms you can convert in pressure and volume, so you will get back this equation. Okay, but we have started with this equation. So always when you calculate the work done, you have to start from the relation which relates between pressure and volume. So we have started between this because this is the governing equation for isentropic. So answer is C. Thank you.